Yesterday, we looked at this kind of problem that had two radical signs in it. What's another name for a radical sign? A square root sign. So if you have two radicals, you need one on the left-hand side of the equal sign and one on the right-hand side of the equal sign, and then what do you do to solve it? Square both sides, and then that gets rid of the square roots. If you have one radical sign, what do? You still square both sides. And the square and the square root cancels out the radical sign. Now you will see the next kind of problem has a lot more steps. The problems that we did yesterday had about 5 steps. How many steps does this kind of problem have that we're going to look at today? It has, well, if you look at your paper, I couldn't fit them all on one screen. It has 9 steps. Why is this one longer? Is this just a simple number over here this time? The 9 steps is when the radical sign equals a binomial. A binomial has 2 terms, and that's what makes this one longer. But we still have the same first step. The first word in the first step is isolate the radical term. Please underline the word isolate, because you can't do step 2 until you've done step 1. The first step is to isolate the radical term, the part with that has the square root. So we'll go through all of the steps in just a minute, but let's go ahead and look at example number 1. So on example number 1, is this isolated by itself? No, it's not. And so that's the first thing that we need to do. We need to get it by itself. Now this is set up like we did yesterday. This is set up with like a 2-column proof. The first column is the math work, and the second column is the explanation written out in words. So we always start with a given equation. That's the equation we're given to solve, and then the next thing we need to do is isolate the square root sign. This 3 is in the wrong place. It's not isolated if I have a plus 3, so what am I going to do to get rid of a plus 3? And that's how we got to this step right here. And then, as it says right here on the front of your notes, the next thing to do is to square both sides of the equation. When you square both sides of the equation, the square and the square root cancel each other out. And that's how you get this without a square root. The square and the square root cancel each other out. And then this is equal to that. This is in the expanded form. We expanded this so that we can multiply it out correctly. Now, the next step, what did they do to get the next step? Well, if you read your steps over here on the first page, it says FOIL. As you know, I do not prefer FOIL. I prefer a box problem because a box problem keeps things organized. Sometimes with FOIL, people miss one of the terms. They do one of the terms twice and they miss a different one. And with a box problem, it gets it all organized. So what they did here is they did FOIL and then they did combine like terms. In the example we're going to do in a minute, what are we going to do instead of FOIL? We're going to do a box problem because my students have been more successful. Now, right here, do you see that when we did that, the x is squared? When x is squared, that means this is now a quadratic equation. I hope you've heard me say bunches and bunches of times there are three ways we learn to solve a quadratic equation. You can solve a quadratic equation by factoring. You can solve a quadratic equation by using the quadratic formula, or you can complete the square. But complete the square only works on certain kind of problems that are set up real nice. The easiest way to solve a quadratic equation is to factor. Before you can factor, it has to be set equal to 0. I have to subtract the 5x from both sides and add 9 to both sides so that it will be equal to 0. So that in this step right here, I can factor it. Uh-oh. Do we remember how to factor? In order to factor, you multiply the first number times the last number, and you get a positive 18. So in your margin somewhere, you write 18, and the factors of 18 are 1 and 18, and 2 and 9. Since this is negative, I need to have negative factors. Can any of those pairs of factors add up to equal to this negative 11? Any of these pairs add up to negative 11? That pair right there adds up to negative 11 because this coefficient here is 1. I can use my shortcut factoring and just take those two numbers and put them in the factors. Hopefully you remember that once you have the factors, then you can solve it by putting the first factor equal to 0 or the second factor equal to 0. That is called the 0 property. And then you solve those two little equations. You add 9 to both sides. That's how you get a positive 9. You add 2 to both sides. That's how you get a positive 2. Most of these problems are going to have two answers. So how many checks am I going to have? I'm going to have to check both of the answers. So how do you check an answer? You plug it back in. This is what I am checking. Plug in the 9, and so 5 times 9 is 45, minus 9 would be a 36. The square root of 36 is 6. 6 plus 3 is 9. 9 equals 9. It's true. So that's a solution. When you, let me make sure you understand that. This is the solution because this was true. When you plug the 2 in, 5 times 2 is 10. 10 minus 9 is 1. Some people had trouble with this yesterday. What's the square root of 1? 1. 1 plus 3 is 4. Does 4 equal 2? That is false. That means this one is extraneous. That's what happens a lot on these kinds of problems. You get one solution and one extraneous. Sometimes they can both be solutions, though. The only way you know is to check. Sometimes they can both be extraneous. But a lot of the time, you have one of each. In example number 2, you can see that they have filled in the steps, and we're going to fill in the math work. So, the first thing is to isolate the radical. The square root part has to be by itself, so what am I going to do with the 3? And that's going to give me 3x plus 7 equals x plus 3. Then what am I going to do? Oops, that was a funny looking parentheses. When you square both sides, the square and the square root cancel each other out. Now, we are not going to do this step because instead of doing this step, we are going to do a box problem. What's going to be in our box problem? So find a margin somewhere. X plus 3, x plus 3. Isn't that what x plus 3 squared means? And so instead of expanding and then foiling, we're just going to go right into a box problem, and that'll get us, we'll get to skip a couple of steps. 3x, 3x, 9. So what do you do with the box? Combine like terms. So we're not going to do that step. We're all the way down to this step where we combined like terms. So we are going to have 3x minus 7. It doesn't have the square root on it because that's what I was looking at. I missed it when I changed side. Okay, so what's this part supposed to be? Y'all help me out. So that's what you got from the box problem. Now, before I can factor, I have to factor it because the x is squared. Before I can factor it, it has to be equal to 0. So I have got to subtract the 3x and subtract the 7 so that it will be equal to 0. And so this is 0 equals x squared plus 3x plus 2. In order to factor, you multiply the first number times the last number, and you write down the factors of 2. There's not a lot of factors of 2. Will those factors add up to equal the 3 right here? So because this is a 1, I can use the shortcut factoring x plus 1, x plus 2. The 0 property tells me that the x plus 1 is equal to 0 and the x plus 2 is equal to 0. Solve those. And x equals -1, x equals -2. Maybe. I have to check. Every single problem you have to check, and you have to check every single answer. It has 2 answers, so I'm going to have 2 checks. Raise your hand if you need a minute on this screen. Okay, so we're ready for the check. So I am going to check x equals -1 and x equals -2. I check those by plugging in the -1 in place of the x. So that's 3 times -1 plus 7. Subtract 3 equals -1. 3 times -2 plus 7 minus 3 equals -2. Under the radical sign, that would be -3 plus 7, so that would be a 4 minus 3 equals -1. But that's not actually a 4. I said it wrong. It's actually the square root of 4. So what's the square root of 4? Is 2 minus 3 equal to -1? Is that equal? That is true. That means that this is a solution. So this is going to be -6 plus 7 what is the square root of 1? Is that true? So that means my solution, solutions plural I should say, x equals -1 and x equals -2, these are my solutions because both of them were true. So do I have any extraneous? So on your paper where it says extraneous, if it doesn't have any extraneous, you are going to write the word none. Okay, problem number 4 on your homework. As you can see on your homework, it doesn't have the 2-column format that your notes do. Your notes have that format, so not only do you have the math work, you have the words written out explaining what we did so that you can look at them. So, step number 1 says to do what? Isolate. If this radical is not already by itself, I need to isolate this, so I'm going to need to add 1 to both sides so that this will be by itself. That's called isolate. Step 2 says to square both sides. You square both sides because the square and the square root cancel this out, and you have to have it out from under the radical sign to be able to solve for x. Now, your notes then say to FOIL, but we're not going to follow that part of the notes. Instead of FOIL, we're going to come over here in the margin and multiply this out with a box problem. That means x plus 1 times another x plus 1. That's what x plus 1 squared means. We're going to multiply it out with a box problem and then combine like terms. So instead of following your notes where it says FOIL, we're going to use a box problem. You can use FOIL if you want to. This is a quadratic because x is squared. If x is squared, this has to be equal to 0 before I can solve it. So I've got to subtract x and subtract 7. So that this will be equal to 0 because all of that's going to cancel out. Factor it. Multiply the first times the last number, and over here in your margin somewhere, write down the factors of 6. Could some pair of those factors, could any of those factors add up to equal 1? Will that pair add up to equal 1? So because this is a 1, I can use my shortcut factoring. My 0 property says that the first factor is equal to 0 or the second factor is equal to 0. I'm running out of space here. Add 2 to both sides to get the first answer. Subtract 3 from both sides to get the second answer. If I have 2 answers, how many checks do I have to have? Raise your hand if you still need a minute here on the screen. So on the right-hand side of your paper, you have space for the checks. We had positive 2 and negative 3. So we're going to check x equals 2 and x equals negative 3. How do we check those? Substitute back into the original equation. So this is going to be 2 plus 7 minus 1 equals 2. This is going to be negative 3 plus 7 minus 1 equals negative 3. So 2 plus 7 is 9. That would be the square root of 9 minus 1 equals 2. Square root of 9 is 3. Is that true? 3 minus 1 equals 2? That is true. That means this is a solution. Okay? So that's going to be square root of 4. That's going to be 2 minus 1 equals negative 3. Is that true? That would be false. That means this was an extraneous answer.